In these next couple of videos, I'm going to show you how to mount your projects on black mat board for portfolio presentation or similar. I'll conclude this lesson with a demonstration video where I actually put a camera on me cutting and mounting the projects. But in this video, I'm going to focus on what I can show you on screen. It's important to get out to your ruler and try measuring as you watch these videos, but don't watch and do on an actual project, because I'm going to start out really general and then show you how to be more accurate as the video progresses. Here's a couple questions that'll be like this or similar on the quiz. Now, as a graphic design student and often as a graphic design professional, you'll be required to mount some of your work on black mat board. Now, you might be under the impression that that's not necessary anymore because now everything is online. But many employers still require an actual face-to-face interview with a printed design portfolio. You generally get the interview from your online portfolio, but more often than not, especially if they're a heavy into print-based work in their studio, they're going to want to see what you've done in print and how good your craft skills are. A lot of people don't believe that craft skills matter anymore, but they really still do. One, it just shows a pride and a love for what you do. And also, if you're going to go into package design, it is essential. And this video is definitely not meant to scare anyone off. You'll hear me use some ugly words in this video like precise measurements, fractions, geometry, but I'm going to show you, some technical stuff, but then I'll show you like easier, more common sense, if you will, ways of getting these measurements. I always can tell that a lot of graphic design students cringe when I show them how to make these measurements in class, because a lot of times we get into creative positions because we're just not good at math and things like that. But graphic design is that unique creative job where it does require, in addition to your right brain creative thinking, it also requires a bit of analytical thinking as well, not only for things like measuring and web design, but also just for concept generation. Coming up with the thing that makes the design very unique isn't often able to be just a purely right brain exercise. The most common substrate for mounting your printouts will be a 15 by 20 inch black mat board. And these boards should be black on the face, the back, and all the way through, and not a foam core. And I will show you one of these boards in the live demonstration, but let me just show you on a website. I'm just showing you the boards here on Blick. Here's a close-up of the corner of the board, and then here's showing you like a stacked package of them, so you can see that they're black all the way through, not foam core. A lot of the times you center the project right on the board, but sometimes slightly above center is better to compensate for visual compression. So let's take a look. So let's use your imagination here and pretend that this is your black mat board, and then this is your printout from the computer. The idea is that you want to glue this on here so that it is either in the center, like you see here. And a lot of times what happens is when you have a big, and we'll call this a mat, if you want to think of it in terms of like photography matting, if you have a big mat in a small photograph, a lot of times putting it right in the center and putting it up on the wall, it feels like it's a little bit too low, and that's just a phenomenon of visual compression. So a lot of times what you'll do is you'll move it up a little bit to compensate for that, and often if you're right on the fence and it's just a little bit too high, that can cause analytical people to have a little bit of a fuss. So you generally want to go a little bit higher, almost to make it obvious that you're going above center. And a lot of times what I'll do, first figure out what my measurements are, which we're going to go over in a little bit, and we say, okay, that's your A and your B, and divide it, put it on the paper, and then you either have to put it on lightly with some tape, put it up on the wall, see how you feel about it. And then I'll try, and if there's an opportunity to make these three measurements the same, that often looks fairly pleasing. So that would look like this, where the measurements on the sides, the top are the same, and then the bottom is whatever is left over. And that just tends to look good. There's no question about, is it higher than it is lower, and there's no opportunity for visual compression because you've more than made up for it by having it extra high. So the way I usually mount this type of work is I figure out what I need for a measurement from the side and from the bottom, and I'll make a line roughly about this big, literally where my pencil's going. It doesn't have to go all the way to the edge. In fact, it's easier to hide if it doesn't, and then maybe starting about here up to here. So first thing we need to contend with is, how do we find these measurements? Well, if you're analytically brained, here's a formula for you. You literally take your board width, subtract out your project width. So board width minus project width divided by 2 will give you this distance. And then you would do a similar thing to find measurement B. But that sounds like algebra. Yuck. Here's a way I think is a lot more just easy, common sense way. Take your paper, put it up to the very top corner of the board, and now measure this distance and cut it in half, and measure this distance and cut it in half. But unfortunately, we still need to contend with being able to read a ruler, which not everybody knows how to do. So let's try to take care of that. So if you measured and the mark came out to 1 tick after 6.5, would you even know how to say what that is? And would you know how to divide it in 2? So let's look at a real example on our work again. If we put a ruler on our work and we measure this distance, it comes out, luckily in this case, to a pretty straightforward measurement. So from the 0 to our edge comes out to 6.5. For now, we'll just write that down. Sides equals 6.5. We know we have to divide that by 2. We'll get to that in a minute. And then we'll take our ruler and we'll measure how much space is at the bottom. Okay, and then starting on our 0 mark. Now, not all rulers have a 0 mark, and we'll talk more about that in a bit, but if they don't, then you would start right at the very edge. And that one comes up to 9 inches. Before we calculate this and finish this off, let's say, what if you didn't know that that was 6.5 on the ruler? Let's delve into the ruler a little bit more before we figure these out. So to get our measurement on the ruler, we obviously start at the 0, or the edge if there isn't an indent and a 0 mark like that. And let's say it came out to here, right? Well, we know that's 1 full inch, 2, 3 inches, and then we have to get at the nitty gritty in here. So if it comes out over here, we say, okay, the easy part is it's 6 plus something else. So it's that something else which is tough to people, is in between the 2 whole numbers. In between any 2 whole numbers, and this could be 7, and this could be 8, in this case it just happens to be 0 and 1, we have these divisions. And most rulers are divided into 16ths. But let's take them in the easiest way possible. I think intuitively we kind of know what these things mean from sharing a pizza with a friend, or 3, or 7, or 15, and you'll see what I mean in a second by that. So if 2 of you are going to share this piece of pizza, cut it down the middle, we each get half, right? And that's pretty even, easy to see translation right here. Right down the middle is 1/2. And if you notice on the ruler, that's the longest line typically. Then you have 2 more lines that are longer than the rest, and that would be, now you got 3 people to share that pizza with. So now you and your 3 friends each get 1/4. quarter of a pizza. So there's your quarter of an inch. There's another quarter of an inch. 2 quarters makes a half, right? Just like you saw before. You put those two together, and that's a half a pizza. Now, if let's say 2 friends take off really quick, and your other friend has a huge appetite, and you're not feeling so hungry, you could say, okay, well, I'll take 1 quarter, and you get 3 quarters, right? So you see it's very, very similar to that. And we can go on and say, okay, the next ones, the 8s, would be like cutting that pizza into 8 different slices. And so the only time I think that it really gets tricky beyond that is what does 3/8 mean? And if you go back to the pizza example, it's really taken 3/8 and putting them together. But what's the difference between, say, like 2/8 and 1 quarter? There is no difference. It's just, it's not considered proper, if you will, to say 2/8. But if you're just measuring something for graphic design and you feel comfortable saying 2/8 instead of 1 quarter, then by all means say 2/8. And so far we've been slicing the circle up, the pizza, to make reference to this ruler, but it's no different than taking a rectangle and slicing it into pieces, right? So this is split up into 8s, so each 1/8 here is the equivalent of 1/8 here. And just like 1/2 of a half is a quarter, 1/2 of a quarter, and you can see it visually here, if you take this and you cut it in half, that's 1/8. And 1/2 of 1/8 is a 16th. But what happens when we put our ruler up to something, and between the 6 and the 7-inch mark, for example, it measures 9/16. So we have 6 and 9/16 of an inch. How do we figure out what half of that is? It seems like it's just quite that easy, that right between the 6 and the 7, it either comes out to a nice even 1/8 or a nice even half. Well, before I answer that, let's go back to our example and work with some easier numbers. Earlier we measured from here to here, came out to 6.5, so we said we need half of that on each side to center this vertically on the board. So if you didn't know intuitively that half of 6.5 is 3.25, then what you do is you go to a calculator and you just have to look at a fraction like the way it's written out. It says 1 divided by 2. And no matter how complicated the fraction is, it's always this number divided by this number is super friendly in a calculator. And we all have calculators on our computers. Usually you just go up to like the search bar and start to type in the word calculator and you'll find it. So type this in just the way you see it, like that. 1 divided by 2, and that'll give you 0.5, 50%, half. And then add your whole number back in. So now you have 6.5, and now just divide that by 2. And so you get 3.25. Now the only tricky part left to this method is you have to be able to take the decimal and translate it back into the fraction on the ruler. But you can make that fairly easy just by Googling decimal equivalent of ruler marks. And maybe you make your own little chart, however you like to read it. This one's very visual right here. So right down the center you have your 0.5 or 1/2 inch, the 2 divisions here, 0.25 or 1 quarter, 3 quarter. As the numbers get shorter, now you're into the 1/8 of an inch mark. So 1/8 of an inch is 0.125. 2/8 is a quarter, which becomes the 0.25, and then you have 0.375, which is 3/8. 625 is 5/8. 875 is 5/8. Those I have memorized from years of woodworking. And then you get into the 16ths, which I don't think anyone memorizes. You just kind of use those as you need them. We'll wrap this part up in the next video.